Alright, so today what we're going to do is we're going to look at hydrate salts. We're going to deal with copper 2 sulfate pentahydrate. So this is copper 2 sulfate, but in it there's actually some water that's bound to those copper sulfate molecules. They're called hydrates, water crystallization or hydrates. And what we're going to do is we're actually going to prove that that is actually what it is. We're going to drive off that water through heating it, and then we're going to test it at the end. So first of all, we need to weigh out about 4 grams of this material. So we're going to start with that. All right, so in order to weigh this out, first thing we need to do is we need to turn on our scales. And then once it's done its initialization, then we're just going to zero it. And then we're ready to use. We're going to put this on a piece of folded paper so we can get it into the ignition tube is what we're going to use. Notice that this material is toxic, so I'm wearing gloves. Definitely a wise thing to do. And if you get it on the gloves, you should replace them. So we're going to weigh out about 4 grams or so of this material. So I'm just going to zero this filter paper. We're going to use this for our measuring. And then we're going to just weigh out about 4 grams of material. Try and be just a little careful with this. All right, that's pretty good. It's close enough. We're going to put the lid back on. It's always a good habit to make sure you put lids back on containers. So if they get knocked over, which that definitely happens, you don't cause a great spill. So if you want to make a note of that mass reading, you can. That's how much we're starting with here. It's always a good habit to note down these readings. If you're not sure you're not going to use it or not, just keep a measurement. Now we need to put this into an ignition tube. So we're going to take this over to our setup, and we're going to work on that next. So we need our setup to be able to drive this water off. So we're just going to set up a simple clamp stand here. So we have the stand and the clamp. We're going to have one tube is going to be at an angle here. And these are ignition tubes. Notice these are much bigger than regular test tubes. They're thicker glass walls, which means that you can use them for heating. This system is actually going to be tilted downwards once we get to that point. But for the moment, I'm just going to leave it like that. The other ignition tube is just going to sit very nicely inside one of these Erlenmeyers. And typical setup for this, we're just going to have this a little higher. We're going to have it just a very slight angle. What we want to be able to do is we want to be able to drive the water off, but not have our material come out of the stand itself. So now we've got that in about the position we want. I'm just going to unclamp this one, and we're going to use that for our material. So the other thing we need to do here is we need to get this material at the bottom of our test tube. Now you can do it by using a piece of fluted paper, where you just make like a little trough with it, or you can use a scrupula if you have one that's the right size. And all we're doing is like just carefully putting it inside that scrupula. If your test tube is dry, you can usually just add this directly. And we lost a little bit on transfer there, but the experiment will still work just fine. So this way we can slide it all the way down in, and then we can just tilt it down. That way we don't get a lot stuck to the sides of the ignition tube itself. So we want to try not to do this too quickly, because what we want to be able to do is have our material stay in the tube as it gets heated. But we want it pointing down, so if we create some liquid water, that liquid water will in fact drip down into the collection vessel. We're just going to clean this up a little bit here. All right, we'll take care of that in a moment. All right, so now we're basically set up to run this dehydration, as it were. So what we're going to do is we're going to turn on the gas for we're going to make sure the slit is closed at the bottom. We're going to grab our flint, turn the gas on, then we're just going to light it. Now, when we heat this, we don't want to put this under like really high heat. That would be very easy to do. If we do that, we can find that we can burn this. So when we heat this copper sulfate, what we're going to do is we're just going to gently warm it at first, and you should see it change color a little bit. It should go like a color's color. If you see it going black, then you're overheating it and you should ease up a little bit. So now what we're going to do is we're just going to carefully start heating this. We're going to do it by hand, so this is not something we do very often, but we're just going to very carefully just warm around this tube and see if we can drive off some of that water. As the water forms, what you might see is some condensation down the tube here, because the glass tube itself is kind of cool, so the hot water comes off and just condenses on the inside of the test tube, kind of like you would see, you know, in a cold winter's day when the water condenses on a window or something like that, or the outside of an ice drink. Notice how it's starting to turn a little bit white on the end here. So that's what we expect to see as the water gets driven off. So we're just going to carefully do this for a little while, and you'll hopefully see as the material heats up, you'll start to see that happening to more of those blue crystals. So you can see here the condensation of the water that's being driven off. So we're not going to worry about that too much, but if we wanted to very just gently warm the tube, that'll help drive that down the tube. But try not to heat the rubber clamps, because those will melt with this kind of heat. So we're just going to keep driving this off for a little while. Alright, so not particularly exciting, but you can kind of see a little bit of bubbling in there. We'll try and drive off that water a little bit. You can see it condensing further down. I'm going to try and catch that if we can. So it's starting to like burn just a little bit on the outside here, so we're not going to heat it too much there. Once you get above about 600 degrees, the copper sulfate itself starts decomposing into other materials, so we're trying to avoid that. But you can see, I'm heating it further down, you can see that water that's starting to actually collect further down the tube. We'll just try driving that down the tube just a little bit. We want to try and collect it, so we don't want to heat the tube the whole way down. We would like to see some of that condensation actually collect into the other vessel. But you can see that a clear change from that blue copper sulfate hydrate that we had at the beginning into this white system right here. Notice how I'm not putting the tip of the blue flame right on the glass, because I'm trying not to superheat this. We can see there's a little bit of charring right here, so some of our copper sulfate has decomposed a little bit, so I'm trying not to do that too much. It's very easy to overheat this system as you do this. But clearly, there's a gas being given off, and that is undoubtedly steam. just trying to heat this as much as we can. So we're going to come back in just a couple of minutes. Alright, so what you should be doing while you're going through this experiment here is you should be writing down your observations. What changes do you observe occurring during the reaction? What did you start with? What was the color of the solid? What did it look like? Was it crystalline? Was it a powder? So in chemistry, one of the most important things is making sure that you're writing down all your observations. So when we started, what did that copper sulfate pentahydrate, the hydrate of copper sulfate, what did that actually look like to you? You should probably make a note of that in your observations. Then as we start heating it, what observations do you see? Does the color change? Does the does the morphology of the crystals change? Was it crystalline? Is it powder? Is it kind of like an amorphous lump or solid? But these are the kinds of observations you should be writing down because those are important when you're doing real research chemistry. And also, do you see other things given off? So clearly in this experiment, we can see all this water being driven off. It's on the sides of the test tube. It's condensed on there. And it's actually collecting, if you look very closely over here at the lip of the test tube, the ignition tube, you see it's collecting. It's got a blue hint to it, so I think maybe a little crystal of copper sulfate was a little further up the tube and just kind of got washed down with the liquid, unfortunately. But the purpose of this is for you to see that as you go through this, you see a very real change in the material, and you see a secondary component being driven off in this case. Most likely going to be water, and we'll prove that later on. So you can see it dripping in the tube now. And we're just about done here, I think. Majority of this system has now been converted into sort of the anhydrous version, or the version of copper sulfate that has no water in it. And we've collected some of that in our test tube so we can test it. So we're going to turn this off now, and we're going to let everything cool down a little bit. Actually, we're going to dry maybe a little bit more water off up here. And we're going to try and do it without melting. Those arms. So we'd like to drive off as much of that water as possible, so that when we go to get our copper sulfate out of this ignition tube in a few minutes, we can do so without getting it wet from the sides of the container. So try to avoid hitting those arms when you do this. Sometimes it's not easy to do. You can see that condensation, or the condensate that we created there, is indeed evaporating away. So I'm just going to do the very top that you can't see very well there. And I think we can finish collecting that. So what we're going to do is we're just going to turn this. Let's turn our flame down. It's the safest thing to do. We're going to turn this a little bit, and with a pair of tongs, we're going to carefully move our ignition tube upwards so that we can warm away the last part of that water, so our test tube is nice and dry when we rescue our anhydrous material. So we can heat this a little more vigorously because it's just the water we're driving off. And you can see it evaporating as I do this. And this is the reason we use the ignition tubes. They're thicker, they're stronger, they can withstand the heat a lot better than a simple test tube or sample tube. And then we can just make sure the bottom is dry too, and we'll just warm the whole vessel. So we're going to give that a minute or two to cool down. We're going to turn off our flame because we don't need that anymore. And we'll be back in just a moment. Alright, so we've let the tube cool down now. So what we're going to see here, we're just going to break it up a little bit. And you can see that what was the copper sulfate hydrate is a very different material now, very different color. And again, you should be making a note of that observation as to what color it is. We're going to bring it over to the scale so you can see there a much better idea of what this material is. We're going to weigh and see how much of this stuff is remaining. So this should give you a good idea of what the material looks like now. We're actually going to weigh and see how much stuff we have remaining. So we're going to use the simple watch glass here. We're going to zero our balance. Remember, we started with around 4 grams. So we're not going to get everything out of here. There's going to be a little bit of loss in here. but this should give us an idea of how much material we have remaining out of that 4 grams, just to give you a sense of how much water we lost during this experiment. So clearly there's a little trace left in here, but you can see that's obviously nowhere near 4 grams. So we clearly had something driven off during this experiment. And you can now look at that and you can get a better sense of the color and the texture of the remaining material after we've heated it. So we're going to take this and we're actually going to split it across 2 watch glasses, and then we're going to do a couple little tests with it just so we can see and prove what we've actually driven off here. So we're going to move back to the side of the bench. So on the watch glass now, you can see that's pretty white. There's a slight hue to it. You can make a note of that. We have 2 watch glasses, and we're simply going to split this material across the 2 watch glasses. Just approximately evenly. It's not too critical what we do here. So we got 2 approximately equal amounts of our final material. And what we're going to do is to one of them, we're going to just add a few drops of distilled water. So we're going to do that with the one on the left. So this is just straight deionized water, sorry, not distilled water. And if you watch that, look at the color that we get from that after we add that. So while it may not have the exact same morphology or like overall look and feel to the crystals or powder, you can see clearly that what was white is no longer white. Right, so you need to sort of make these observations. So we add water to this. We go back roughly to what we started with. Now we also have a little bit of liquid that we collected. Now we've been saying it's water this whole time. So here's the ignition tube that had the collected material, and we're just going to pour that to the other side, and we're going to see if it looks the same or not, so we can make a deduction as to whether it is actually water or not. When that adds, you can now look at those 2 dishes. So on the one side over here, we added deionized water, and to the other side, we added the condensate that we collected in the other ignition tube. And you can clearly see from that that these are the same materials. So we can make a deduction as to what it was that we drove off the reaction. And you should make a note of that in your data tables. All right, so in this lab, what we're going to do today is we're going to determine the amount of water that's present in a hydrate. So hydrates are basically usually inorganic compounds, just like organic compounds that have water of crystallization. Basically, this water is adhered to the surface in a fairly loose way that it can be driven off with a little bit of heat. So today what we're going to do is we're going to take a known hydrate, or an unknown hydrate in this case, sorry, and we're going to actually heat it until such time as all the water is being driven off. And once it has, we're going to determine what % composition in that system is actually water. So the basic setup is going to be, we need a heat setup. So we've got our ring stand and our gauze already set up. We have our Bunsen burner. I'm just going to plug that in so it's ready to go. We have our lighter, so we can light that later on, and our tongs, so we can move our crucible around. And in case you've never seen a crucible, basically the crucible looks something like this. And we have a lid, and we can put stuff inside the crucible. And then once it's on there, then we can basically put it on our Bunsen burner, on the heat source, and we're going to try driving off the water. A couple of little hints and tips. First of all, we need to make sure that this is dry. So what we're going to do is we're going to heat it with nothing in it at first, so that we can make sure it's nice and dry. Then we're going to let it cool down. Then once we've got our hydrate in there and we're heating it, note what we'll do at first is we'll just have that lid slightly ajar. It will not be sitting on fully on top. We want to allow any water to evaporate and escape out of the system so that we can make sure we actually drive that out. So that's sort of like fundamentally what we're going to be doing. You should have got that from the pre-lab reading through this. So here's what we're going to do. First of all, we're going to start by turning on our gas, and then we're going to light it with our flint. Then what we're going to do is we're actually going to heat this crucible empty. I'm going to just turn that up a little bit. Now we can do this part with a pretty high heat, because all we're trying to do is dry it, so we need to make sure this is open, right? So very carefully just going to lift that lid over a little bit. And we're going to allow our system to, just going to place that on here. And we're just going to allow our system to dry off. We want to make sure as much water is driven out of this as possible. So there we go. And we're going to leave it like that for a few minutes. We're going to let that heat, and then once we're going to do, we're going to take that off and let it cool down, and I'll come back to you at that point. Alright, so our crucible has been drying on the Bunsen flame for a while now. It's been about 5 minutes. So what I'm going to do is I'm just going to carefully put that lid back on top. And we need to let this cool down before we do anything else. So carefully using my tongs, I'm just going to place it on another iron gauze mat so they can cool down carefully without burning or damaging the crucible. And now I'm just going to turn the gas off for the moment. So we're going to let that cool down, and then we're going to start taking some measurements and start weighing what we need for this experiment. Okay, so our hydrate is now, our crucible is now nice and dry. So what we're going to do is we're going to weigh it. So first of all, we need to do is we need to turn our top pan on. So we're going to turn that on. We're going to keep the lid closed while we go through this. All right, once it's gone through its initialization sequence, we'll open it up so we can use the top pan just like we did before. I'm just going to re-zero out of habit. Then what we're going to do is we're going to lift our crucible onto the top pan. We're going to just remove the lid. And we're going to put that next to it. So now what we do is we are getting a reading of our empty, dry crucible. So you should now have that measurement there. Then what we are instructed to do is add 2 to 3 grams of the unknown hydrate. So what I'm going to do here is I'm going to add that. And remember, approximately means between 2 and 3, which means anywhere in that range will do. So we're going to just add a little bit at a time here. We want to make sure we don't spill around the crucible. So we're going to put just a tiny bit more in there, just to put us in that 2 to 3 range. All right, so there we go. We have a little bit over 2 in there, so we should make a note of that reading as well. So now we've added somewhere between 2 and 3 grams of our unknown hydrate to the crucible. So we're going to take this as our initial reading. Notice the little balance mark is up, so we can use this reading. 31. You see the flickering in the last digit again, so make a choice as to which one you want to use, but that looks pretty stable there. So that's what we're going to use. And since that is the digit that dictates our precision, we do see some flickering in that. So now we have our initial reading. We're just going to lift the lid onto our crucible, and then we're going to collect our crucible here, and we're going to move it over to our stand. Once we've got our crucible on the stand, we're just going to relight our Bunsen here. We had that turned up while we're doing while we're waiting for it to cool down and taking our initial measurements. So we're just going to relight that, and we're going to get a pretty good flame going here, and we're going to heat this. Notice I remember said we have to just crack the lid on the crucible here, just so we can let any water evaporate. And what we're going to do is we're going to let this run for about 5-6 minutes so that we give it a chance to drive off the water, and then we're going to re-weigh the entire crucible contents. Alright, so we've been gently heating this crucible now for about 5 minutes. For the second part of this first heating, what we're going to do is we're going to actually turn the heat up so it's like a more vigorous heating method. See how the blue cone is forming there? You may not be able to see it, so I'm just going to turn the light up just for a second so you can see that. Notice that now we have a blue color. It's just a little bit below. I'm still not very aggressively heating this, but I'm trying to heat it a bit more to try and drive off a bit of the hydrate water. And so we'll do this now for about another 12 minutes, and then we'll come back and we'll let it cool down and take our first measurement. All right, so we've now heated this for an additional 10 minutes, so it's time to turn our heat down. And we're just going to move the Bunsen away from what we're dealing with so we don't burn ourselves. We're going to carefully place the lid back on the Crucible, and we're going to carefully, again, just bring that off of the wire gauze and put it on another one for it to cool. Once it's done cooling, we're going to weigh this and see what our mass is after we've heated it for this period of time. Alright, so we're going to take our measurement after the second heating and see if we have any real change here in our water content. We should always make sure, of course, as habit, we should zero this. And we get our reading from the second heating. Alright, I think we're good there. Maybe a fraction, but it's in the least precise digit on our measurement. So we're going to put that back on to heat for a third time. Alright, and so we're going to do one last run of this, a third one, just to make sure there's no more water left in it. So we're going to place our Crucible back on our gauze. We're going to place our flame back underneath, and we're going to turn it up pretty good this time. One last drive. Got to make sure we take the lid just ajar a little bit there, just to make sure the water, any water left, can evaporate. All right. So it's been on there for about 10 more minutes. We're just going to turn our flame down, move it out of the way. In fact, we're going to turn our flame off this time. This should really be the last run. We're going to take our Crucible and we're going to put it on the other gauze again to let it cool down. All right, so we've let our Crucible cool down from the third heating. We're going to put that on for one last reading. Should make sure it's zeroed. Then we can place it on there with the lid. We'll let that last digit settle. Alright, so I would say basically no change. So I think we have our final data point here. Now we can use all this information to actually calculate what the percent by mass water was in that initial hydrate, which is unknown in this case.